Next is Gay-Lussac's law, the gaseous law. The remaining two laws we want to see, Gay-Lussac's law and Avogadro law. This law relation to pressure and the temperature. Its law states that at constant volume, pressure of a fixed amount of gas is varies directly with its temperature. That is directly proportional to the temperature. At constant volume, pressure of a fixed amount of gas varies directly proportional to with the temperature. So the mathematical expression, like there is P is directly proportional to T. So we are using the proportionality constant here. So P is equal to K3. Already the K1, K2 is finished. That is in previous law, Boyle's law and Charles' law. So P K3 into T. So that the final term will be that P by T is equal to K3. This relationship that is can be derived from of the Boyle's law and the Charles' law. So pressure versus temperature. That is the constant molar volume. So that here also gives a straight line. This is called iso. Called this isochore. I will draw the graph that is between the temperature and pressure. So pressure and the temperature. When the different volumes, what is that? In constant volume, pressure of a fixed amount of gases varies. So here the fixed amount of gases varies means like this. This is volume 1, volume 2, volume 3 and volume for different volume. That is the temperature in Kelvin scale. 0, 100, 200, 300, 400 like this. Then temperature like this. See that the volumes are like this. The volumes like V, that is V1 is less than V2 is less than V3 is less than V4. So like this. So this graph is called isochore. That is the isochore means the pressure versus temperature graph of the gases. So this is called Gay-Lussac's law, the relationship between the pressure and the temperature. Next is the Avogadro law. Avogadro law is volume amount relationship. Here this law states that the equal volume of all gases under the same condition of temperature and pressure contain equal number of molecules. This means equal volumes of all gases under the same conditions of temperature and pressure contains equal number of molecules. Contain equal number of molecules. So this is called Avogadro law. So this means that so long as the temperature and the pressure remains constant, so temperature and pressure remains constant, so that volume depends upon the number of the molecule of gas, or other words, that is amount of the gas. That mathematical expression is volume is directly proportional to the n. That is here the n indicates the number of moles of the gas. This number of moles of the gas. here the proportionality constant we have to introduce. So V is equal to K4 into N. So the number of molecules of 1 mole of a gas has been determined already. That is, we know that 6.022 into 10 to the power 23. This is called Avogadro constant. That is the same number of which is came, that is the already we discussed in mole concept, that is in mole definition, discussion definition of the mole unit. So here the volume of gas is directly proportional to the number of moles. So volume of gas directly proportional to the number of moles. So that is the 1 mole of each gas at STP, that is called standard temperature and the pressure. Standard temperature, STP indicates standard temperature and pressure. So here that will have the same volume, standard temperature and the pressure means that is 273.15 Kelvin. That's exactly what 0 degree Celsius. That is and the pressure is 1 bar. That is exactly what 10 power 5 Pascal. So 10 power 5 Pascal. That is the pressure. So these values approximate freezing temperature of water and the atmospheric pressure at the sea level. So at STP, the STP molar volume of an ideal gas or a combination of an ideal gas, that is 22.71098 liter per mole. Some molar volume of liters we can discuss, gases will we can discuss here, that is argon, that is molar volume in liters per mole of some gases at 273.15 Kelvin and 1 bar, that is STP is argon is 22.37, carbon dioxide is 22.54, dinitrogen, this N2, dinitrogen is 22.69, dioxygen 22.69, dihydrogen 22.72, and ideal gas 22.7. So these are the molar volumes, that is the per mole of a gas is at 273.15 Kelvin and 1 bar. 273.15 Kelvin at 1 bar pressure. So here the number of moles of gas can be calculated in the form of this N is equal to M divided by capital M. Here this M is mass and this M indicates the molar mass. So here we can apply this value, that is V is equal to K4, that N is equal to what? M by M. Okay, this on rearranging this equation, that means the molar mass is equal to K4 M divided by V. So already we knew that there is mass by volume is what? Density. So M is equal to K4 into D. So here the D is the density. So we can conclude that is the density of the gas is directly proportional to its molar mass. So a gas that follows Boyle's law, Charles' law and Avogadros' law, that is strictly called an ideal gas. So Boyle's law, Charles' law and Avogadros' law called ideal gas. So such a gas is hypothetical. It is not assumed. It is assumed that the intermolecular forces are not present between the molecules of an ideal gas. So the real gas follows these laws only under the certain specific condition when forces of interactions are practically negligible. So in all other situations, the deviation from the ideal behavior. So we will discuss the ideal gas equation later.